unfortunately I couldn't be physically with you this year, so I'm here virtually. I'm a former fashion and textile designer and lover of nature and materials. I've been working as a designer since 2014, more or less, in the luxury fashion industry through the whole creative process, with my own couture house since 2011. Though I always been searching for innovations, especially focusing on renewable materials and inputs. I believe that biology is the best technology, if we can call it, and therefore nature the greatest inspiration. And I hope that this will replace the old methods of extracting raw materials through linear practices towards a circular and renewable one. More or less 5 years ago, I discovered biodesign, and this opened me a new perspective. Of the Biodesign Hub was born and aims to be a platform that connects design, art and biology in order to collaborate and develop creations based on renewable circular inputs, but also to foster innovations that inspire material value chains to become more resource efficient, circular, and reduce the carbon, greenhouse gas, and water footprint. All this, of course, in line with climate, energy, and sustainable development goals for a future of a more sustainable industry, let's say. These are some examples of the materials which are made from circular bio-based inputs, such as, for example, mushroom leathers. These are different type of leathers created from mycelia of the mushroom. Here you can see solid mushroom-based objects that are used the same type of mushrooms and always reacts different depending on what you feed it. So we can create also solid objects. In this other, you can see matte leathers made of coconut, bark cloth, wood waste, and even fish skin waste. These are bioplastics made of algae and other biodegradable inputs such as bio-waste for different purposes or haptics. I will go explain more in detail about these materials. So, talking about biodesign. Biodesign is a term used to indicate design of, for, or with biology. Biodesign can be defined as a non-disciplinary creative practice in which reconnecting, learning, collaborating with nature, we find the most powerful tools to create infinite possibilities of creation as an alternative way of living more sustainable. Through understanding biological process and incorporating the use of living materials, we find more circular possibilities to replace the old linear methods of creating and sourcing materials from extracting raw materials from fossil fuels and other non-biodegradable resources towards the new renewable. All this as a means to incorporate the inherent life conductive principles of biological living systems into design processes and transition into a more holistic, circular future. So biodesign goes further than the many biology-inspired approaches to design and fabrication. Unlike biomimicry, that is imitating nature, cradle to cradle, and the popular but vague green design, biodesign refers specifically to the incorporation of living organisms or ecosystems as essential components in design, enhancing the function of the finished work. So it goes beyond mimicry to integration and use, dissolving boundaries between the natural and built environments and synthesizing new hybrid typologies. Today, industrialization and urbanization have disconnected most people from nature, and they lead their lives unaware of the origins of the foods they eat, the textiles they wear, the materials they use, and our daily waste. Unaware of the connections also between their behaviors and the environment around them. So, biodesign is a powerful tool to reveal this connection. It offers an opportunity to imagine and explore alternative ways to live. So these changes that we cause to the climate and environment are now compounding crises. So biodesign offers a glimmer of hope, let's say, that we might face these global problems without triggering a slew of new ones. In fact, we are deliberately turning the world that was found into a world that is sort of made. Now is the time, I think, to take full responsibility and start to make more self-aware decisions. These are not decisions that can be left in the hands of a selected few. So, biodesign represents an emerging and often radical approach to design that also draws on research from the life sciences and even incorporates the use of living materials into structures, objects, and processes. So from designing for ecological enhancement to the use of speculative design and art as teaching tools, let's say. So taken all together, biodesigned projects reflect an overdue shift in societal priorities towards sustainable approaches to building and manufacturing. This unifying purpose is driving increased collaboration between designers and biologists, an essential ingredient in many of the projects, and offers also thrilling new forms and functions. Biodesign is being also promoted by scientists and designers as an ecological remedy, a technological challenge, an economic opportunity, and a manufacturing and industrial revolution, I think. So designers are collaborating with nature, forging meaningful connections between humanity and the earth. The work is inspired by and intertwined with nature like never before. So reflective of our transforming relationships to the natural world and compelled by a sense of urgency, designers look to nature as a guide and partner. This growing interest in biodesign is driven by a range of factors. One is rising concern about the ecological and social effects of the Anthropocene, humanity's ever more visible impact on Earth, alongside the equally visible failure of earlier green movements to mobilize change. So this paradox is increasingly complicating for the contemporary industrial design profession, since capitalism requires a continuous cycle of production and consumption to keep designers in work. So this burgeoning movement celebrates alternative ways to make things, such as growing biodegradable textiles, growing materials, packaging, etc., for consumer products. All this to creating using renewable inputs such as algae, all kind of bio-waste, mushrooms, and integrating also to each other. So biodesign harnesses living materials, whether they are cultured tissues or plants, and embodies the dream of organic design, watching objects to grow, and also after the first impulse, letting nature, the best among all engineers and architects, run its course. It goes without saying that when the materials of design are not plastics, wood, ceramics, or glass, but rather living beings or living tissues, the implications of every project reach far beyond the form or function, equation, and any idea of comfort, modernity, or progress. So design transcends its traditional boundaries and aims straight at the core of the moral sphere. toying with our most deep-seated beliefs. So in designers' ability to build scenarios and prototypes of behavior lies a power that they should protect and cherish, and that will become even more important in the future. So Biodesign has provided also new technologies with powerful tools, bridging the natural and the manufactured world. And ideas that were once confined to speculation are increasingly becoming reality. For example, this shift has been on full display in different events around the world, such as, for example, the annual Biofabricate Symposium, to mention one, in New York, which since many years celebrated important launches such as Modern Meadow, animal-free, liquid leather, Ochoa, bold threads with the silken fibers, spun from yeast, along many other promising new prototypes and concepts. So in recent years, and with increasing frequency, various bio-prefix words have entered the lexicon of industries, ranging from outdoor apparel and performance sports to luxury fashion, as you might hear about the bag from Hermes made from mushroom, Lululemon projects, Stella McCartney, just to mention a few. So, but they all include the likes of bio-based, but also biomaterial, biotechnology, biosynthetic, biofabrication, or biodesign, among others. So evidently there is a general lack of aligned understanding of these bio terms, and in its absence, many cases of incorrect use, causing confusion all around. Due to the vagueness of a term like biomaterial, that is generalized assumptions are made, such as if it's bio, it must be better, or if it has bio in the name, it must be biodegradable. So, which is actually not really the case, but I'm not gonna go deep into that. So there is an impressive variety and number of case studies that involve organisms at all scales, from plants and animals to bacteria and cells, to be used as textile, architectural, graphic, or interior elements. Architects, for example, working on wet buildings that adapt to changing environmental conditions and levels of occupancy, almost as if they were living organisms. Designers also concocting new diagnostic and therapeutic tools that they rely on animals and plants. Engineers devising new self-healing construction materials, creatures themselves becoming the infrastructure of entire architectural systems. Despite the multitude of conversations and investigations happening in this space, biodesign remains a burgeoning industry that will benefit from increased public support and financial resources if it's to become truly viable at a global scale, and that's what we hope. So I hope that perhaps our relationship with nature will be able to fix it from within. On the Stone Age, for example, did not end because humans ran out of stones. It ended because it was time for a rethink about how we live. So in the same way, I think we are living different times now, but kind of something similar is happening. Therefore, the desire to follow nature, to adhere to its underlying forms in the pursuit of harmony and beauty can be traced back to antiquity. So as answers to all these questions unfold over time, the space for also cross-disciplinary collaboration and creativity prompted by scientific research will only expand. Propelled by global imperatives such as the urgency to develop and implement cleaner technologies and the rise of do-it-yourself biology. So all this convergence of fields, as well as of the expert with the amateur, is ultimately necessary to support the ongoing effort to alleviate negative impacts of the legacies of the Industrial Revolution. and it will lead to the reconception of the primary design principles of value, generation, growth, and sustainability. So as Steve Jobs said, the biggest innovations of the 21st century will be instead the intersection of biology and technology. So I think a new era is beginning, or already beginning, some time ago. There is some important facts to take in account, talking about fashion especially. So in the fashion and textile industry, I think innovation is desperately needed to radically improve fundamental processes within the supply chain, which is still largely based on century-old methods and technology. Textile and fashion industry today are also an acute example of our endeavor to disrupt and destroy the very natural resources we depend upon to thrive as species. We are consuming our natural resources faster than they can regenerate. And I think we must learn to design with self-replicating and dynamic living properties. Instead of designing out life, design with it and for it. As a context for textile research, also creative design education is fast adopting learning strategies that embrace more sustainable values. There's new economic models such as circular and bio-based industries are emerging, and with them a whole new range of design toolkits. So introducing science to the design practice will enrich and bring a full new range of design thinking to also develop new possibilities of different applications on the industry, to innovate on the creation of new inventions. As science also understanding and learning the design thinking through cross-collaboration will broaden the horizon of different possibilities of applications on the industry, of how technology can be applied on their creations, etc. So I think design and science profession will need to transition to this new context. And the recent rise of biodesign highlights also the beginning of an emerging and profound paradigm shift for design and science. And I think is promising to work on cross-collaboration. So these are also some facts about the fashion industry that you might know is very very clear. So if it talks in terms of carbon, the fashion industry produces almost 10% of man-made CO2 emissions, which is more than aviation and shipping combined together. On top of it, fast fashion clothing is actually and usually manufactured in Asian countries or third world countries where most factories run on coal and gas, without mentioning going more into detail. In terms of waste, 85% of all textile goes to the dumps each year and do not just not biodegrade, but also the chemicals from these garments release methane gas that goes on the atmosphere, and other very toxic chemicals from these clothes end up on the fresh water and in our oceans, of course. 35% of all materials in the supply chain end up as a waste before even a garment or product reaches the consumer. So if we say that by 2050 is reviewed to have 10 billion of people that needs to be dressed, and this represents the need of 300 million tons of non-renewable inputs. In terms of water, textile manufacturing is the second largest consumer of the world's water supply, and it's responsible for 20% of all industrial water pollution worldwide. There's another 2018 report from the International Union of Conservation of Nature estimated that 35% of all microplastics in the ocean came from the laundering of synthetic textiles like polyester. So producing materials actually with bacteria, or when we said making with mushrooms, uses around 500 times less water on the process compared to the usual process. I mean, these are just a few facts, and I'm not going to go into very much into detail. In terms of soil, surveys show that nearly 5% of landfill space in the world is consumed by textile waste, just by waste. And it pollutes land and makes it useless and barren in the long run. Surveys also show that cotton consumes the highest amount of harmful pesticides and fertilizers. And even when some clothing, some textile says like EcoCert, BioCert, there's a very big story into the transparency of this type of label. So all the majority of all of these textiles fall on land while they are sprinkled on the crop. Similarly, textile manufacturing units releases hazardous waste into the nearby land. So in general, if we talk about clothing, most clothes in the world are made using fossil fuels. Oil-based polyester is the most commonly used fabric in the world, actually, with nearly 60 million tons produced in 2019, for example. And fashion's second favorite fiber is cotton. It's a product with a very complicated environmental footprint whose present links to modern slavery are as problematic as its past. So shifting the raw material supply chain is an immense opportunity. The growing momentum behind more sustainable and regenerative agricultural practice holds out the prospect to not only mitigate fashion's footprint, but perhaps one day enable the industry to have a net positive impact. I'm going to talk a bit about circular economy in terms of fashion and textile is a bigger idea than incrementally reducing the harm of our current model. Circular economy tackles the root causes of global challenges, such as climate change, biodiversity loss, and pollution, while creating opportunities for better growth. It is underpinned by three principles that are all led by design. That is, eliminate waste and pollution, keep products and materials in use, and regenerate natural systems. So for fashion, it means ensuring that products, that is apparel, footwear, accessories, are used more, are made to be made again, and are made from safe and recycled or renewable inputs. So a circular economy for fashion creates better products and services for customers. It contributes to a resilient and thriving fashion industry as well, and regenerates the environment. That is the most important thing. So in delivering the vision, the rights and equity of all people involved in the fashion industry are prioritized. So the circular economy for fashion creates new opportunities for growth that are distributed, diverse, and also inclusive. It also targets a state to innovate towards, realizing it will require collaborative efforts by industry and government, significant investments, a large-scale innovation, transparency, and traceability. Yet by thinking actions and taking actions together to get started today, it can scale actually quite fast. So I think the time to act is now. In a circular economy for fashion, products such as apparel, footwear, accessories, etc., are increasingly based on renewable energy and materials. A circular economy is based also on three principles, all led by design. That is, one, eliminate waste and pollution. 2, keep products and materials in use and regenerate natural systems. So when I mean waste, are materials or substances that are discarded and no longer used. So typically resulting in landfill, incineration, or leakage into the environment. In terms of use more, business models that keep products at their highest value, like rental and re-commerce, are the norm across the industry, decoupling its economic development for resource and from resource consumption. Products that are also designed and manufactured to last and align with the business model that will deliver them. For example, in rental models, considering the durability and ability to repair the products. Businesses empower users with the necessary knowledge, tools, and services to maintain the physical and emotional appeal of their products. Also, all products that are made that have to be used, excess inventory is minimized and is never destroyed. Is where also relevant products are enhanced or replaced by virtual alternatives such as digital collections or virtual showrooms. In terms of made to be made again, it means that products and their materials are designed and manufactured to be disassembled so that they can be reused, remade, recycled, and where relevant, and after maximum use and cycling, safely composted. Landfill, incineration, and waste to energy are not part of a circular economy, obviously. So another fact is that packaging has to be minimized and made from reusable, recyclable, or compostable materials, and more broadly in line with the vision of a circular economy for plastic and equivalent for other packaging materials. Another thing, products are also in practice collected and sorted to be reused, remade, recycled, and where relevant, and after maximum use and cycling, composted. Business contribute to support infrastructure commensurately with what they put on the market to ensure their products are collected and reused, remade, or recycled in practice. So governments support effective collection infrastructure, facilitate the establishment of related self-sustaining funding mechanisms, and provide an enabling regulatory and policy landscape. In terms of composting, composting is the process by which materials biodegrade through the action of naturally occurring microorganisms and do so to a large extent within a specified time frame. So the associated biological processes will yield CO2, water, inorganic compounds, and biomass, which leaves no visible contaminants or toxic residues. Design for disassembly. It's a design principle that enables the product to be taken apart in such a way that allows components and materials to be reused, remade, or recycled. Recycling is a process of reducing a product back to its basic material level, reprocessing those materials and using them in new products, components, or materials. So in recycled material, for example, material that will have been disposed of as waste, but is instead reprocessed by means of a manufacturing process and made into a final product or into a component for incorporation into a product. Remaking. Remaking is an operation which a product is created from existing products or components, and this operation can include disassembling, re-dyeing, restyling, and other processes to improve emotional and physical durability. In terms of made from safe and recycled or renewable inputs. In a circular economy, substances that are hazardous to health or the environment are designed out to allow safe material circulation, and ensure that no pollutants are released into the environment. So moving away from a take, make, waste model, circular economy aims to decouple production from the consumption to finite resources. All this is achieved first and foremost by drastically reducing the need for virgin inputs through reuse, remaking, and recycling, and then by sourcing the remaining virgin inputs from renewable materials using regenerative production practices, like working with biomaterials such as mycelium, algae, or food waste. For example, using renewable materials. A renewable material is a material that is composed of biomass from a living source and that can be continually replenished. When claims of renewability are made for virgin materials, those materials shall come from sources that are replenished at a rate equal to or greater than the rate of depletion. And regenerative production practices. So regenerative production practices build soil health and carbon content, increase water quality and biodiversity, and improve the resilience of ecosystems. And very important, the health of people and ecosystems must be protected by ensuring in these facts. So its products and their materials are free from hazardous substances, compounds exhibiting intrinsically negative properties such as being persistent, bioaccumulative and toxic, very persistent and very bioaccumulative, carcinogenic, mutagenic and toxic for reproduction, or endocrine disruptors. Production and use of products do not discharge hazardous substances into the environment. Microfibers that may cause harm are prevented from reaching the environment either by design or collection. Textile fibers or fragments of textile fibers that are shed from the product during production, use, and after-use phases. Production, supply chain practices, and technologies ensure the effective use of resources, for example, by optimizing the use of water, energy, chemicals, and materials. Production, including inputs used during manufacturing and processing, is fully decoupled from the consumption to finite resources. That means that the need for virgin resources is minimized by increasing the use of existing products and materials. Production byproducts are minimized and where unavoidable are treated as valuable materials. Post-consumer recycled content is used both to help decouple from finite feedstocks and to stimulate demand for collection and recycling. Where virgin inputs is needed, it is from renewable feedstocks sourced using regenerative production practices. The manufacturing, distribution, sorting, and recycling of products is powered by renewable energy. And the last, but not the least, that is very important is transparency and traceability. So achieving the vision will require transparency and traceability across the value chain, for example, on product specifications, chemical inputs, materials used, and production practices. So such information will be crucial to inform after-use practices such as sorting, remaking, and recycling. So traceability is the ability to trace products, components, and materials, as well as the social and environmental conditions in which they were made along the whole supply chain, including after use. Transparency is the ability to make information, for example, on a product specification, chemical inputs, materials used, and production practices. So available to all actors of the supply chain, including users, allowing common understanding, accessibility, comparability, and clarity. Materials in the circular economy can flow in two cycles, the technical cycle and the biological cycle. The technical cycle products and their materials can continuously cycle through the system so that they can be maintained at their highest value at all times. So for fashion, all materials, including biological materials such as wool or cotton, should first be cycled through the technical cycle loops of reusing, repairing, remaking, and recycling. And where relevant materials can then enter biological loops, such as composting or anaerobic digestion, to generate additional value, for example, by increasing the health and carbon content of soil. Circulation of materials is enabled by keeping different technical materials separate or easily separable, as not doing so can hinder recycling, as well as keeping biological materials and technical materials separate or easily separable, as not doing so can hinder also recycling and composting. So these are just a few points about circular economy and how biodesign practices and biomaterials are part of must be design practices must be part of circular economy. These things I think is all for my side, and thank you very much. I hope you're enjoying the rest of the festival, and I wish you all my best. Goodbye.